Hi student, in last video I explained about the concept of transducers. Now we have to discuss about classification of transducers. So I have to show that different major classification of transducer. The first one is based on principle of transduction. Second one is primary and secondary transducer, and third one is passive and active transducer. Fourth one is analog and the digital transducer. Fifth one is transducers and inverse transducers. So in first classification, based on transconduction, it is subdivided into various classification, various types. That is called resistive transducer and capacitive transducer and inductive and piezoelectric and photoelectric, electromagnetic and the thermal electric. So these are all the classification under the basic principle of transduction. So first, what is the transduction? Transduction means convert one form of energy into another. So that is called conversion. So other name is called conversion. So here various conversion methods available. So because these are all the conversion methods. So first one is resistive. In resistive transducer, it is works on the principle of change in resistance. So the change in resistance will occur means it will produce some output. Okay. How it can be possible? So the resistivity of the material can be changed, or otherwise the length of material, maybe length of resistance can be varied, or otherwise area of the conductor to be varied means the output of the resistance will be varied. So here the general formula of resistance R equal to rho L by A. So here rho is the resistivity of material, L is length of conductor, A is the area of the conductor. Just you have to change the any one parameter, the resistance value automatically changing. So here you have to change the resistance value based on area means increase the area, it is inversely proportional, the resistance will be decreased. Okay, so you have to reduce the area of conductor, the resistance value is increased because it is inversely proportional. So resistivity, rho is the resistivity of material, it's a constant, so there is no problem. Each and every material having different resistivity. L is nothing but the length. Yes, you have to increase the length, resistance value is increased because it is directly proportional. Otherwise you would decrease the length means the resistance value automatically decreased. Okay. So in resistive transducer, uh, like a potentiometer device, resistive strain gauge, or Pirani gauge, or heat wire, heat or hot wire meter, resistive thermometer, and thermistor. So these are all the under category of resistive transducer. Okay. The application, next one, the application of resistive transducer. So where it is can be applied, it means to measure the pressure. Okay, just we got to measure the pressure in any area, just we got to using resistive transducer, or otherwise measurement of displacement or force or torque or a gas flow or a gas pressure or otherwise a temperature or radiant heat, the heat of radiant, and also the measure the humidity of the air also possible using resistive transducers. So It is based on the change in resistance. Okay, just the principle is change in resistance. Okay, so next one is capacitive transducer. Here the principle is change in capacitance. Change in capacitance. So where how can it is possible? Okay, how can the change of resistance value? Not it is a how to change a capacitance value. So the principle of capacitor is that means the construction of capacitor is two metal plates in between having a dielectric material. Okay, either positive charge or negative charge. Just you have to change the distance between the plates. Okay, distance between plates, or just you got to move the plate either upward or downward direction. So otherwise it is also change the capacitance value. So uh, these capacitive transducers are like a variable capacitive pressure gauge or a capacitor microphone. So capacitor microphone is used for our mobile phone also. So microphone is having it is to convert the physical quantity, that means the voice is converted into electrical quantity. Okay, and otherwise dielectric gauge. So here is the application where it is a capacitive transducer used means to measure the displacement. It is also like as a resistive transducer, measure the displacement or pressure or speech. Okay, I already told that speech or music or noise, liquid level and thickness of some materials. So these are all the application of capacitive transducer. So next is inductive transducer. It is based on principle of change in inductance. So here resistive transducer means change in resistance, and capacitive transducer means change in capacitor. Inductance means change in inductance. So how to change the inductance value? So just we got to see the equation of inductance. L equal to n square mu a divided by L. So n is nothing but number of turns in the coil. Turns. Mu is the resistivity of the material. Resistivity of the material. A is nothing but area of conductor. L is length of conductor. Just you have to change any parameter, you have to get the change in resistance value. Okay. In inductive transducers are like a magnetic circuit transducer or a reluctance pickup transducer or differential transformer like LVDT or other eddy current gauge to measure the eddy current in the circuit, or a magnet restriction gauge to measure the magnetic fluxes, and Hall effect sensor to measure the current. For this the purpose of to measure the current. And the application of inductive transducers are to measure the pressure, displacement, vibration, or positioning of system, position, force, or thickness, and sound and magnetic flux or light or radiation. So these are all the few examples of inductive transducer for the application area. Next one is piezoelectric transducer. Second, next option is piezoelectric transducer. It is a principle of uh, just to take any crystal material, just any material, take any crystal material, just you have to apply the force on any one side. That means this compress or nothing but stress can be applied any side of the crystal. At the time the crystal molecules are internally changing, so the molecules can be moved. It can be generate few amount of voltage, so it is like as a transducer. For example, the proper definition is an EMF generator when an external force, okay, when external force is uh, applied to the certain crystalline material. Any type, the various types of crystalline materials available. Just to take any material, just you have to apply the force uh, and get a output voltage. Just you have to take output voltage. It can be output voltage like as either millivolt or microvolt only. Okay, just you have to, it is to be connected to any signal conditioning unit and get amplified and to utilizing for various purposes. Okay, this is the concept of piezoelectric transducer. Next one is photoelectric transducer. Photoelectric. So it means a voltage is generated in a semiconductor junction device. Okay, any semiconductor junction device when radiant energy stimulates the cells. Okay, that's nothing but a photodiode, like a photodiode. The semiconductor device, light falls on the diode, it will conducting. Okay, it will generate the, it will conduct the voltage. So the application of the transducer is used for to measure the light. Okay, that means the unit is lux to measure the light. For example, real time example is all are watching a cricket match, something the light falls to goes under minimum low level, means they have to using take some meter to measure the light. uh, that means light, that means that meter is called light meter. So normal to measure the light condition based on the surrounding area. So what are, how much amount of light sources are available. So that is a concept of, that is the application of photoelectric transducer. Next one is electromagnetic transducer. Electromagnetic transducer. So these transducers work on the principle of the change in flux linkages due to the change in reluctance. Either change in flux or change in reluctance in the circuit, which produces the output voltage based on the change in flux. Okay, so principle is change in flux. So the flux will be changing, the automatically the output will be changing. Next one is next type of transducer, thermoelectric. Thermoelectric. These transducers are working on the principle of the conversion of input temperature. Okay, input temperature into equivalent electrical signal. So the input is temperature, the output is electric signal. So this is a thermoelectric transducer. Okay, so these are all the classification under the based on the principle of transconduction. Okay, so this is called these are all the various conversion process methods are available in transconduction principle. Okay, so remaining topics will be covered in next video.